to Future Print Tech Fest. I'm joined by David Heath, who is Technical Marketing Manager with Meteor Inkjet. Welcome, David.
Thank you. Welcome. Hi.
Really fantastic to have you here. Meteor have always been a real supporter of some of the work we've done with Inkjet and so on, not least because they're one of the kind of Cambridge innovators. So they have a wealth of experience with specifically drive electronics and software, and they work with a lot of the key components within the, I guess, the chain when we're creating new inkjet printing machinery. So they have a very good and pretty independent view of that. So David, I think your talk is going to be called sort of selecting inkjet print heads. Is that correct?
Yeah. So industrial inkjet printhead, making the right choice, basically.
Yep. Yeah, so brilliant. So in line with the vision of the event, it's about helping people make the right choices with inkjet. So I'm going to hand everything over to you now, David. So thanks very much. And I look forward to speaking to you at the end.
Thanks. Hopefully you can see that. My name, as it said, David Heath, and I work for Meteor Inkjet. So today I'll be taking you through this presentation. It's industrial inkjet printheads, making the right choice. Now, the industrial inkjet world covers a wide variety of applications. So we're looking at textiles, the ceramics, the functional 3D printing, signs, displays, deco, product decoration, labeling, and packaging. And it's just boomed, the last decade. And we've seen a big rise in the functional 3D recently. Some of the plateau in some of the markets for the ceramics and textiles. But there's always improvement. So as print heads are getting on and better every year, those markets are reaping the benefits, basically, from newer drive electronics and newer print heads available to the market. My presentation agenda is going to cover the differences between the piezo printhead types, the printhead selection, fundamentals of driving the printhead, data throughput, scanning, and single pass applications. Just touching on those to take it through the positives. So differences between the piezo printhead types. We're looking at the architectures, meaning the faceplate and the internal, the number of nozzles and the packing density, so the nozzle per inch or DPI, the nozzle diameter accuracy, ink supply behind the nozzle, chemical compatibility, commercial models for inks and waveforms. So without further ado, let's look at the different modes that we've got in the print heads. I'm going to focus on the three here that are highlighted: the shear, bend, and push modes. There's also a fourth mode we'll talk about at the end of these. So the shear mode has a shared wall technology adopted by Tsar, Seiko, Konica, Toshiba, just to name a few. And this is where the PZT, or the piezo, is going to be bent inwards to the walls, forcing the ink out of the nozzle chamber. So the whole wall will flex inwards and outwards with the given voltage, and of course the waveform driving behind that, which we'll talk about later. Here we've got the bend mode adopted by Xerox, Dramatics, Epson, Kyocera. So where the PZT is lying flat on top of the nozzle chamber, and it bends in and out of that chamber, forcing the ink out of the nozzle. And again, the voltage being applied to it is controlled by the waveform. And last one on here, we've got the push mode adopted by Trident, Ricoh, and Xerox. So looking at the image on the left-hand side there, we've got a stack of PZTs laid upon each other. And when voltage is applied to that, it pushes down on that diaphragm, which is just above the nozzle chamber, forcing the ink out. And on the right-hand side, we've got the PZT on its side, whereas this time it expands into that transducer foot, pushing again down onto the diaphragm membrane. I should say most of these nozzle channels and the nozzle chambers are sealed and kept, keeping the electronics away from the inks. But of course, you need to talk to the head vendors to make sure your inks are compatible, and we will come across that later. The last one I want to talk about was the MEMS technology, which has taken off in recent years. we've got Dematic, Tsar, Konica, Ricoh, and Epson, just to name a few, who are adopting this technology, where you have a large piece of silica, which is then etched by using masking layers. So you can create the nozzle chambers and the nozzles themselves, making it very, very accurate. And then there is a sandwich layer of silicon at the top, and above that, the PZT pushing back down onto those plates and forcing the ink out in much the way that the bend mode, as the example shows here. Next, we're on to the nozzle plate technology, looking at the faceplate of the head itself. This comes into play when you're looking at different ink types. So where you have the nickel, stainless, polyimide, and silicon plates. Not all of these plates are compatible with all inks, obviously, and getting the right wetting characteristics for the plates and the inks is essential. Talking to the head vendors, they will definitely be steering you in the right direction on these, and looking at the compatibility of this. When you talk to the head vendor, they'll be able to give you a kit which you can immerse within the ink and just see how the different parts of the print head react to it. The faceplate in particular is important. Obviously, you don't want the ink to wick around that nozzle and block it whilst you're jetting. And just for that reason, the nozzle has its own different formations. And you can see two very different formations there. I think the bottom one being a Tsar 1003 and the top one being the Dematic Starfire. But they're just examples to show you how different these nozzle structures can be. They are formed by etching, laser drilling, punching, electroform, or MEMS technologies. Some being more accurate than others, and probably the limitation being the materials that you can use. So what is in a waveform? And this is where we come to what's driving that piezo to force the ink out of those nozzles. So to achieve binary and grayscale printing, as the example shows here on the left, you've got, in the case of the binary printhead, a single drop size, whereas in the grayscale, you've got 3 drop sizes in this example. And to produce these for the binary, we've just got a single pulse. For the grayscale, we've got 3 consecutive pulses, and here's how they work together. So if you can see the A droplet there on the far left-hand side is the first droplet to leave the head. The B is then following it and catching it up in flight. C, being a larger pulse, will catch up to the 2, and by the time it reaches the substrate, hopefully all drops have merged together with no satelliting to create the print. Now, a very effective way of doing it, and amazing that it works as well. And looking at the pulsing, we can actually see the waveform files in most of the head types. And again, we'll come to that later on. And it's very interesting to see the effects of the waveform on that drop velocity and the size of the drop. Here are some specifications I think should be considered when you're looking at a prototype system, or the first system to go into production. So you're looking at the printhead sizes, widths, number of nozzles, nozzle rows, number of colors that are supported within the printhead itself, including the drop frequencies and the power requirements behind it. But I think this table, if you just look through and consider, have you thought of these aspects, such as the temperature and the heater, could be an inbuilt heater for the printhead, or this could be a heater which is in the ink system. Therefore, a little bit more control for the inks. But all aspects to take into consideration. Now we're on to the number of nozzles. The first head we've got at the top here is the smallest for a laboratory size. My example here is the Dematic DMC 16 nozzles. So you're not going to probably use this on a production machine unless it's a single pass, very narrow width, or multiple scans, but you're probably looking at tens of scans just to fill an A4 sheet. Next, moving on to the smaller size of head. So this is the kind of 100 nozzles or more, up to 1,000. So we've got from Tsar 128 up to the Toshiba Tech CF1 at 636 nozzles. And then moving on to the medium size heads, 1,001 nozzles up to 2,000 nozzles. The Tsar 1003, Dematic Starfire, and the Ricoh MH5421. Then the larger size of heads, so 2,000 nozzles and up to the 3,000 mark. There's Dematic Samba. Now I must iterate, this is number of nozzles. This is not head size by any means. So you've got Dematic Samba is about 1 inch coverage of print, whereas the Ricoh is just a little bit over that. But you can see there's a great difference in the number of nozzles in the head, and that's the density, which we'll come to on the next slides. And last of all, we've got the largest print heads, so the 3,000 up to the 6,000 nozzles, being the Epson S3200 all the way up to the Tsar 5601s. So looking at nozzle packing and density, we can see the Kyocera there on the bottom left as an example for the trapezoid, showing how those nozzles are tightly packed together in 16 by 75 positionings, and you get 1,200 nozzles per inch just from that small trapezoid. Then looking across to an example like the Tsar 2002, I believe that is, the 2x2 formation of the nozzle rows, giving you 720 dpi. Very different packing densities, the way the nozzles are tread, and so we can see on different print heads, you can't just go by the whole print width for the resolutions. There's a lot to consider in here. Then we've got the nozzle diameters, of course. So smaller drops being kind of high resolution printing, meaning the Dematic Samba W series, the Xerox, Ricoh MH5220s, and the Epson i3200. So the smaller drop sizes if you really want the accurate positioning. And then you're looking at medium drop and large drop. I should say the positioning is probably not the right terminology for it. It's probably more of the detail that you want in the image itself. Most print heads can now achieve multiple drop sizes, but back in the initial stages, a lot of them were binary. And we come on to the Dematic's print head example here. So what I'm trying to compare here is the nozzle size and what kind of grams per meter squared you can achieve. So the SG 1024, looking at two variations of it, the larger drop being 91 for the medium version and 182 for the large, quite a considerable difference from 44 to 68 grams per meter squared. Obviously, it's worth then talking to the head vendors, what variations of this head type do you have, just to get the correct nozzle diameter and the drop size you require. And the nozzle accuracy is specified by the head vendors themselves. So they will specify something like a 1 sigma to plus or minus 5 millirad. Now, how that equates, as this bell curve describes on the left-hand side, is roughly 68.2% with a 1 sigma can achieve a 5 millirad. So that is over a throw distance of 1 millimeter, you can get a jet deviation of something like 5 micron. If you're comparing that from one head vendor spec to another, so something like 2 sigma with plus or minus 3 millirad, you may be thinking, well, is it 1 sigma the best, the 2 sigma with a larger millirad? Well, looking at 2 sigma, is 95% or even more of the jets in the printhead can achieve a 3 millirad jet straightness. So what we're trying to say there is that 2 sigma with plus or minus 3 millirad is probably a better spec than 1 sigma plus or minus 5 millirad. Not saying that you'd pick the better spec over the first, because it's all coming down to these different aspects and properties of the printhead. One may be treating the ink in a different way, meaning it's localized heating of the ink, which may be more preferable to your project. Now we're looking at the ink supply behind the nozzle. So where we've got an end jetting or a side jetting nozzle, or a continuous ink flow through the printhead, the benefit of the continuous ink flow is probably the improved ink priming times, as well as enabling fast nozzle recovery and preventing the settling of heavy pigmented inks, and improving the opening time of a fast drying ink then. So with the side jetting, you're replenishing the ink that's actually in the nozzle chamber as well as in the nozzle walls. With an end jetting, you're relying that the ink is not going to sediment or combine in those corners and very hard to reach places within the printhead itself and block them up. So consider as well the electrical current that's running through these printheads and conductive inks that you may be choosing to use, and whether they are compatible. So talking to the head vendors, perhaps there are tests done already. If these are inks that you're using in-house, you may want to have a test rig set up just for this purpose. Here are some of the commercial models for the inks and waveforms. So the manufacturers like Dramatics, Epson, Konica, Ricoh, Seiko, Tsar for the 1201, and Xerox all allow the users to see and manipulate the waveform files very easily. Whereas Kyocera, Toshiba Tech, and the majority of the Tsar printheads are locked waveforms. And the reason for this is that they want to check the inks in-house, and you get a certificate basically confirming that ink is compatible with that printhead in the certain tests that are required. So going down each path, this might be something you need to consider if it's an ink that you're using in-house and you don't want to particularly let everyone have access to. So printhead selection, since we've now looked at the differences between the printhead types, there's quite a variant selection. So Dramatics, Epson, Konica, Ricoh, Seiko, Kyocera, Toshiba, Trident, Tsar, and Xerox. Now, I've mentioned Trident in there as well because over years we've covered this this Trident printhead, and it's still there available in the market. Let's have a look through how many of these industrial printheads there are and what the specifications can be. So, looking through the suggested selection step process, I would say that selecting the media type first, then the ink type to move with that media. So what is compatible with the media? Going back and forth and looking at, does the media stretch or swell in the wrong way, or does it shrink? Does it become brittle? These are the kind of things you want to look at before even delving down the path of looking at a printhead. So then moving on to the choice of resolution or resolutions. Meaning that you can have multiple resolutions within one machine. So you may want to have a 360 DPI resolution for the bottom layer. And then similarly on the top, you could have a much higher resolution, like a 600 DPI. And the reason you'd want to do that is to have a white underlayer and then the color levels on top of that, just to build up the good vibrancy in the inks. You can then look at the grayscale or the binary modes of printing. Not all heads can actually use the grayscale mode. Some are just binary. So that kind of narrows down the field already, especially for the resolution. You might find that you need a much higher resolution than some of the heads can produce. So you can start to narrow it right down. Then choosing the print head, basically on the physical head size as well as the resolution, of course. And how many heads you need in a machine. So how much do you need to cover in a single pass? Or if you're doing a scanning application, can the head support 4 colors, which would definitely reduce the number of heads that are in the machine itself. And then looking at the print system layout. So again, with the scanning, do you need a mirrored view? And if you're bidirectional scanning, or are you scanning in a single direction? And with the single pass, do you need to look at different color bars and how far down the line they go, how you treat the media as it goes through? It could be UV, and therefore you've got multiple stations of UV pinning. And then calculating the whole cost, including drive electronics software, etc. on the top, and see if a time to market opportunity exists. There are also system integrators out there, and they do a great job of helping people along the way. What is the best solution for them in their experience? So let's look at the head selections. So the Dramatics, shear, and bend modes. Here's a table that just kind of covers most of the heads and the particular properties I found from these data sources. So this isn't saying that all this is 100% true. This is the data that I've been able to pull through from history and from these data sources. So you can possibly take a screenshot of this and review at your own leisure. I'll be going through all the head vendors and how these little parameters are basically narrowing down your search. So whether you're looking at the number of nozzles or the inks that are compatible with the print head, the drop size available, print width, the DPI, and then grayscale or binary printing. And then finally, we've got the maximum jetting frequency. So how fast can this print head run if you're doing single pass kind of, you may want a much higher frequency that's achievable. So here we've got the Epson heads. And again, I'd like to iterate, because I couldn't find anything that covers the oil. That's not to say that Epson don't have a print head available for it. It's just that from these data sources I have available to me, I couldn't find one. We can Malta. The Kaysera, again, nothing in the solvent column, but it's not to say that they don't support solvent. Always talk to your head vendors to find out what is available. The Ricoh, Seiko, and Toshiba Tex. The Trident is in there because over many, many years it's been used in corrugated printing. The Tsar has such a wealth of information available on their websites, but there again, talk to the head vendors and you'll find if there are other variants available for that ink set. And then finally Zbox. So now we've gone through the printhead selection. Let's look at the fundamentals. So the initial stages, you're looking to have compatibility of your inks with your printhead choice and your media choice, getting that balance. Then perhaps looking at a waveform test rig or a test rig for the fluid and delivery system are great for the prototype stage. This way you can basically weed out any kind of issues with system stability and make sure you can optimize for the RIP, screening, color management, and any kind of the image handling in the process. The Dropwatcher can do this for you as well, where you've got a time of flight, a drop volume, and you can view these as well as sending image data through in the Dropwatcher environment. So you can test an image on a production run on a Dropwatcher machine and see how the waveform can be manipulated over that time to make sure you've got all your nozzles working. And to talk about that even further is how quickly can you get 100% of your nozzles working? How sustainable is that? As in, do you have to stop for maintenance within the production? Or do you have a long time, perhaps? Maybe you can get through 3 or 4 production cycles before you do maintenance and recovery. And if you need to recover, how do you go about doing that? Perhaps you could send it back to your head supplier under a warranty, or maybe it's just a case of flushing out. And we've got the electronics data path sitting above the printhead. This can deal with a lot of the image issues that you're coming out with. So things like banding in the print or a continuous coverage from a printhead can be dealt with through the software. And also the electronics data path can hold on to the image information so you can keep up with your production runs. And here's an example of a data path sitting next to the PC. So it could be USB or Gigabit E connection. You can look at multiple heads and how this scales up in a production machine. So your prototype might have 1 up to 4 heads perhaps, whereas the production machines could be 20 heads per print bar and 6 print bars in the machine. But you should look at the drive electronics and see if that scales quite nicely with your solution of printhead. There again with the software, we're just covering the color management, the screening can be done for the imaging. And perhaps there's some feedback from the PLC and electronics to see what's going on with the ink systems. This is all very useful then from the data path side, and choosing your head choice and whether the data path can support that too. Then we look at a data throughput. So data throughput, we've got 12 color planes, 5,312 active nozzles in this example. And to summarize, basically the volume of print data comes down to your frequency, the number of nozzles and print heads that are in the system, and the number of bits per pixel. So the bits per pixel is how many gray levels you want out of it. If you're just looking at binary, then that's much a lower number. If you're looking at some of the grayscale printing, you've got the kind of typical 2 and 4 bit per pixel to give you the 7 gray levels. Here's some examples of the Dematic Samba. So with 3 Sambas in the system running at full frequency with a single bit per pixel, meaning this is going to be a binary, not grayscale. You've got 73.2 megabits per second. So an amazing amount of data that needs to be sent to the heads. And likewise for the Kaisera, there's 2 Kaiseras in the system, again, being binary rather than the grayscale, and there's 81.1 megabytes per second. So fantastic amounts of data going through that data path to the print head. Here are some additional examples of production machines. I'll leave that with you just for a second. So this is where we have looked at a customer solution. So in this example, 80 heads or 480 heads, and looking at how much data goes down there. And that total is right, is 23 gigabits per second. So the type of environment and the PC required does have a heavy cost on the machine as well. And last of all, we've got scanning positives and single pass positives. So why would you choose a scanning machine? Well, it's looking at the complete image. We don't need the full image before you can start a scan. You just need the first couple of scans to get going. And as the scans go out on the printer, you can start feeding it more data. This is the benefit of the data path on the scanning environment. Bidirectional printing allows you to cover up a lot of the issues, such as missing nozzles, streaks, and bands. And there's also many options to correct for drop accuracy in the scanning environment. You've got forward and reverse scanning at different areas. So you've got a kind of reverse scan factor so that your print head trajectory of the ink is different in the forward pass compared to the reverse pass. And you basically have to counteract for that. But scanning does a very good job of having 2 different types of offset. And then with the single pass positives, you can add variable data as you're going. You can have a print flat environment where the print is uniform across the carriage. You can have reliability, adding in spit marks in between the prints because your media is broken up into sections perhaps. And you've got synchronization with the cutters and cut marks. I'd say here as well, you could store a lot of repeated images. So if you're repeating the same image, you can store that once into something like an SD card or the memory on onboard RAM, and just run a production cycle again and again and again. Whereas with the scanning environment, to do a production on a very small area is probably not as cost effective. And that's it. Thank you very much for your time. And please let me know if you've got any questions. And please get in touch soon. This is the crew at Meteor, based in Harston. And here's our regional sales and support areas across the globe. Thank you very much.
Thank you, David. That's brilliant. A really helpful educational session there. Huge amount of what comes across in it in terms of although you've made it very understandable, it's quite a complex decision-making process choosing the right head.
Yes.
Or if you're an OEM or if you're a converter or a printer and you're thinking, I need inkjet, you really do have to spend time in sort of really considering the options, right?
Yeah, I'm trying not to put anyone off here as well. It's just saying what the best process I've found through the years, and I think it's probably 12 years in digital print now in inkjet, and what that process is doing is making sure that you're not going to come across any pitfalls. Doing things like changing your inks and changing your media whilst you're doing prototyping can be a very expensive thing, because as soon as you change your ink or your media, you start to rethink whether your print head is then suitable. So it's like almost throwing everything out and starting again. And relationships can get strained as well with projects that are going along those lines. But hopefully if they stick to these kind of guidelines, then yeah, things will go through quite nicely. And with that in mind, obviously you work as a business with the entirety pretty much of inkjet heads. Bit of a trick question in a way, but is there a specific head that just does
everything that you can say, look, just choose that, that's fine, it can do pretty much anything? Or is that too simplistic?
It's so simplistic.
Yeah.
No,
Yeah.
I think is the easiest answer. Even sticking with a particular head type, you'd probably find that head type is not suitable. I mean, you might have several projects that you're running, something like where a hot melt application, for instance. There's not many heads out there that'll support a hot melt application. Whereas if you're doing a scanning application, all the heads that Meteor can support do scanning applications, and we have used a lot of them in scanning with customers. But there are definitely heads that you'd say are probably best suited to one type than another, especially when it comes down to looking at nozzle size and drop volumes as well. The tables I was trying to basically show there is that I hope that you can narrow down quite quickly what head types you need, and it might not be just one supplier. You can mix and match different head types within one machine. So you could have a very large drop with a low print frequency because of the lower DPI, but then putting on top of that several different inks from different head vendors as well, just to complicate the process even further. But you can mix and match drive electronics, so it makes the a lot more exciting than for the prospects who are actually choosing the print heads and which ones to use. There's a lot more flexibility now than there was probably 6 or 7 years ago. There's a lot more heads out there, so it's a much harder choice to make.
You need to sort of spend time in making that choice. Collaboration with other component manufacturers, ink producers, obviously head manufacturers, integrators and so on. How critical is that in your view to a successful project?
Definitely goes a long way to have that relationship with the ink vendor or the head supplier. They may have seen a project that's like it, probably won't be able to talk about it due to NDA agreements, but they may still be able to point you in the right direction of this print head will work at that speed with the associated ink. You know, if you're picking an ink that's particularly solvent ink, and your ink supplier will say, yes, that works with your media. Do you know we've actually used this in this print head? And you're already starting down the path of choosing which head is best for your application. So they've got knowledge as well in the background. System integrators are fantastic and far few between, or if you can find one, they're usually very, very busy because they're so good at what they do. Talking to the head vendors, it can be difficult to get 1 or 2 print heads at the very initial stages of a project when you're talking to head vendors, and the turnaround times can be quite a shock to new people to digital printing. But yeah, just persist with it. You'll get there with the head vendor and the ink manufacturers helping you along. I think that's the best solution.
Okay, superb. Well, thanks so much for that. Very interesting, very useful. Appreciate that, and look forward to having you back again at a future event. So thank you very much.
Thank you very much.